Hello everyone. Shear wall structures are one of the most common forms of building structures. A shear wall is a wall cast in place using reinforced concrete. In buildings or other structures, shear walls primarily resist horizontal and vertical loads induced by wind or seismic forces, thereby preventing structural shear failure. Therefore, they're also called wind-resistant walls, seismic walls, or structural walls. To understand shear wall construction drawings, we first need to learn the plane representation methods for shear walls. The PINFA plan-based representation standard reflects the ingenuity and wisdom of Chinese engineers and technicians. It serves as a unique graphical language for construction drawings in China, embodying the innovative spirit cultivated through years of practical experience. Shear wall construction drawings using the PINFA standard are divided into two forms: the schedule notation method and the section notation method. In this lesson, let's first learn the tabular annotation method. First, components of the schedule notation method for shear walls. Structurally, a shear wall system can be regarded as an assembly of shear wall columns, wall webs, and coupling beams. The schedule notation method represents shear wall construction drawings using the PINFA standard by listing the corresponding numbers from the layout plan in separate schedules for shear wall columns, wall webs, and coupling beams, and by drawing cross-sectional reinforcement details and annotating the dimensions and reinforcement quantities to represent shear wall construction drawings using the PINFA plane method system. In addition, whether the construction drawings adopt the schedule notation method or the section notation method, they must also provide tables or equivalent notes indicating the structural floor elevations for all basement and above ground levels, the story heights, and the corresponding level designations. Furthermore, the position of the upper structure's fixed or restrained parts must be clearly specified. First, let's get to know the numbering rules for the three types of components in shear walls. 1.1 Numbering of wall columns. The numbering of shear wall columns consists of two parts: the type code and the serial number. Wall columns can be divided into four types: constrained boundary elements, constructional boundary elements, non-boundary hidden columns, and buttress columns. Their corresponding codes are YBZ, GBZ, AZ, and FBZ, respectively. Serial numbers are generally denoted using Arabic numerals, for example, YBZ1. Constrained boundary elements include constrained boundary hidden columns, constrained boundary end columns, constrained boundary wing walls, and constrained boundary corner walls, all using the code YBZ. Constructional boundary elements are divided into constructional boundary hidden columns, constructional boundary end columns, constructional boundary wing walls, and constructional boundary corner walls, all using the code GBZ. 1.2 Numbering of wall web. The wall web numbering consists of a code, a serial number, and the number of rows of horizontal and vertical distributed reinforcement, with the number of rows shown in parentheses. The format is Q plus serial number, number of rows. For example, Q1, 3 rows, indicates wall 1, with 3 rows of both horizontal and vertical distributed reinforcement. It should be noted that when the number of rows for both horizontal and vertical distributed reinforcement is 2, it is not necessary to indicate it in parentheses. Third, numbering of wall beams. The numbering of wall beams consists of type code and serial number. By type, wall beams can be divided into coupling beams, coded as LL, among which those with hidden diagonal bracing reinforcement are coded as LL-JC. Those with cross-diagonal reinforcement are coded as LL-JX. Those with concentrated diagonal reinforcement are coded as LL-DX. Those with a span-to-height ratio not less than 5 are coded as LLK. Hidden beams are coded as AL, and boundary beams are coded as BKL. Now, let's learn about the contents of the shear wall column schedule. In addition to indicating the wall column number, it is also necessary to include the cross-sectional reinforcement diagram and specify the geometric dimensions in the shear wall column schedule. Furthermore, the start and end elevations of each segment of the wall column shall be specified, segmented from the base of the wall column upwards at locations where the section changes or where the section remains unchanged, but the reinforcement changes. Additionally, the longitudinal bars and stirrups for each wall column segment shall be specified, and all indicated reinforcement values must match the cross-sectional reinforcement details shown in the drawings. Next, let's review the contents of the shear wall web schedule. In the shear wall web schedule, it is necessary to indicate the wall web number and the start and end elevations of each segment, segmented from the wall web base upwards at locations where the section changes or, if the section remains unchanged, where the reinforcement changes. In addition, the specific values of horizontal distribution bars, vertical distribution bars, and tie bars must be indicated. Tie bars can be arranged in either rectangular or staggered quincunx patterns. In the drawings, parameter A represents the spacing of vertical distribution bars, while B denotes the spacing of horizontal distribution bars. For rectangular arrangement, the spacing of A and B shall not exceed 200 mm. Whereas for staggered patterns, the spacing of A and B shall not exceed 150 mm. The spacing of tie bars in both horizontal and vertical directions shall not exceed 600 mm. When the construction drawings do not explicitly specify, it is recommended to adopt the staggered layout pattern. The shear wall beam schedule includes the wall beam number, the floor number where the wall beam is located, and the elevation difference at the top of the beam. The elevation difference at the top of the wall beam refers to its vertical offset relative to the finished floor level (FFL) of the structural story where the beam is located. Use a positive value to indicate beam top above floor level, and a negative value for beam top below floor level. In addition, the specific values of the upper reinforcement, lower reinforcement, and stirrups of the shear wall beam shall also be specified. Generally, the top and bottom longitudinal bars of shear wall beams should be arranged along the entire beam span. Stirrup specifications must include type, diameter, spacing, and legs. That's all for this lesson. Have you all gained a basic understanding of the schedule notation method for shear walls?